Hello, hello. Today I have Sometimes Lines Get Messy, some being the addition sum, by physicist from Funen. I don't know how you say Danish cities. I don't think I've done a puzzle by this setter before. So let's see how it goes. Normal Sudoku rules apply. So the digits 1 to 9, ones each in every row, every column, and every marked 3x3 box. On teal lines, that's these, the endpoints, that's those, sum to the product. Sorry, the digits between the endpoints sum to the product of the endpoint digits. Okay, so these two are going to sum to those two. So this could be, say, 3, 3, 3, 1, 9 would work. Or 4, 2, 4, 2. Hold on, that doesn't work. Yeah, no, it doesn't work. But, because of Sudoku, it doesn't work, but it could otherwise work. So I'm just turning off my pencil marks. Okay, so that's how those work. Renbans, purple are renbans. Let's do the shorter one. So these are the digits, some set of consecutive digits in some order. So it could be 1, 2, 3, 4, 5, 6. Or maybe it could be 3, 4, 5, 6, 7, 8, right? So some run of numbers, but can be in any order on the line. And then gold lines are both. So this is both a renban and a product sum line. I don't know what the name for those. I've seen these before. Seems to me maybe I did an icy fruit puzzle with them. Anyway, I don't know what you call those. And then one more rule is that no lines contain identical sets of digits. Okay, so those 3 digits will be a different set. They can share digits, presumably, otherwise we'd run out of digits. So they can share digits, but it'll be a unique set. So if this is 2, 4, 8, this could not also be 2, 4, 8, something like that. Okay, let's try it. I'm tempted to start here because this is a renban. So these digits are from 1 to 8 and 9, because if this is 1 to 7, that's 8, 9. If it's 2 to 8, it's 1, 9. And if it's 3 to 9, that's 1, 2. Oh, yeah, I was thinking there's only 3 choices for the sum here, but that is not relevant. It's this sum equals this product. So probably best to start here then. We've got all this tangle. So, okay, so here we have an 8 length renban, and here we have a 4 length renban. So these 4 digits are all together, and then these 4, I guess, don't all start together, because these could be like 3, 4, 5, 6, and this could be 1, 2, 7, 8 or something. But if we do have something like this, is that going to break this one? Yeah, it would have to, right? Because if we had digits, ooh, but what if this were 1, and this were, say, 6, 7, 8, and this were, say, 2, 3, 4, 5? Could that work? 6, 7, 8, like 5, 4, 3, and this would be, yeah. We could have something like that. So these don't need to be, Okay. Well, let's just try this line then, because there probably aren't that many 4 length. This is the only length for renban product line. So probably aren't that many choices, right? So if 1, 4 doesn't work, because we have 2, 3 in the middle, doesn't work. I'm sure there will only be one thing that works. Okay, so this is, if it's 2, 5. Wait, hold on, I gotta be careful, because they don't have to be the largest and smallest. I mean, I think in practical terms they do, but so let's just be a little more careful. If these are just 1 to 4, if one of the ends is 1, then the other end I mean, neither end can be 1 because I can never make 2 digits equal the other. Like 2 plus 3 doesn't equal 4. 4 plus anything definitely doesn't equal 2 or 3. So 1 would not be at the edge. 2, 3 at the edge would be 6. 1, 4 in the middle would be 5. That doesn't work. 2, 4 is also too big. 3, 4 is way too big. Okay, so 1, 4 doesn't work. How about 2 to 5? 2 and 5 at the end doesn't work. 2 times 4 works, actually. So we had 2, 4, 3, 5. That could work. So that's possible. Does any other arrangement with 2, 3, 4, 5 work? 3, 4 is 12. So 2, 5 is 10, doesn't work. 2, 3 is 6, doesn't work. 3, 4 is, yeah, no, okay. So that's the only 2, 3, 4, 5. How about 3, 4, 5, 6? Okay, now we're too high because even the smallest two product together, 3, 4 is 12. That's 11. So if I make the product bigger and the sum smaller, that's not going to help. And as I go up, it's just going to get worse. 20 versus 13, yeah. So this is, in fact, 2, 4, 3, 5. I mean, I can ignore these other lines. Just this length 4 gold line has to be oriented like that. Which means this has to have 6, 7, and 8. It has either 1 or 9 in addition. And now I'm thinking about, well, maybe I can do this then. Because there's no way this is 1. Because 1 times 4, 1 times 2 means this sums to 2, which is silly. 1 times 4 means this sums to 4, which is not as silly. 3, 1 would work, except this is also 1. So this is not 1. So this is 6. This is fairly big. Which I think is going to get rid of 4, because 4 times 6 is 24, which is too big. So that's 2, that's 4. This can't be 9 then, because that would be 18, which is too big. Even 2 times 8 is 16, which would be 7, 9, which is too big. So if this is 7, oh, and now 2, 3, 4, 5, 6, 7. Oh, except that if this is 2, 7, this would be 5, 9. I have 2 and 9 on this tiny renban, so that doesn't work. This is a 6. These sum to 12. 3, 9 is not going to work, so this is going to be 7, 5. 2, 5, 6, 7. This has to be, oh no, I broke it. What did I do wrong? Hold on. Well, let's back up to here. 4 times 6 is 24. There's no way those add to 24. So that is a 2. 2 times 9 is 18. That can't sum to 18. Oh, that's not the endpoint. I'm silly. This is endpoint with here. And oh, and they sum to all those. Oh my. Okay. Oh, this endpoint is the big one, actually. Which I would almost know this. Okay, hold on. Let's try this again. 1 times 4 is definitely too small for this. That's not 1. 2 times 9 is 18, which is definitely going to be too small as well, because if it's 2 to 9, these would be 3, 4, 5, 6, 7, 8, which is 33 or so. So that is not 2. This actually has to be a 4. It's the opposite, because it's this bigger line. So what I'm going to end up with is, I guess I don't know the sum of this yet, because I don't know if 1 or 9 is on here. So let's just, I mean, if I knew whether this is 1 or 9, so there's essentially 2 different equations I'm checking. It's hard enough to check one, so I'm just going to check the cases. Like, could this be 24? Now I'll get rid of 10. And this line is either 44 or 36. Which means if I take away 10, it would be 34 or 26, which is not 4 times 6. So this is not 6. 4 times 7 is 28, and that's 11 off. 11 of 44 is 33, which doesn't work. 11 off of is 25. That doesn't work either. 4 times 8 is 32. That's 12. 12 off of 44 is 32. So that does work. So that's possible. 4 and 9 is 36, and it's 13. That's not going to work because that's odd. But just to check, 13 off of 44 is 31. No, that's not 36. And 13 off of, well, if it's 9, it has to be that. It has to be 9. So it's got to be 44 minus 13. Yeah, it doesn't work. So that's 8. These are, what do we say? 12. This has to be 6, 7, 9. So this has to be 5. Oh no, this could be 5. Okay, how's this going to work? 4, 8 needs 5, 6, 7, and 3 or 9. One of these is definitely a 5. 6 and 7 definitely be here. Does this have to be this? I don't think so. 3, 5, 3. Hold on, let's do this one. 4, yeah, because 4 times 9 is going to be way too big. 36, that's only 4 digits, which don't repeat, so that's not 9. 4 times 6 is 24. I mean, I think it's going to be too small, but actually that might be right. 8. So if this is 6, well, let's try a 7 actually first. 4 and 7 is 28. We would need a 6 and a 5 is 11. 19. 9 actually works. So 9, 5, 9, 7, 6, 7, I think. Like this, I think works. Let me just make sure that's right. 17 and 11 is 28. 20, yeah, so that works. Does it also work with 6? So I would have 5, 7, 8 is 20. Oh, and only 4 left. No, that one doesn't work actually. So this is a 7. And it's, what did I say this had to be? I need a 6 and a 5. So 5, 6, and 8 is 19. Plus either 3 or 9 to get to 28 is going to be 9. So these are 5, 6, 9. I really don't know the order of those. And this is the other. So this is this actually. That's a 3. Highlight those in purple to tell myself that they're the same digit. And these did end up being, but that was a hard fought battle that those had to be the same. Okay, this is probably known. 12, and it's a renban. It's a renban, so that can't be a 9 actually. This is just a renban. That's a 6. This is 3, 4, 5. I actually probably should have done this first. It probably would have been available right from the start. That's not 9 anymore, or 2 actually. So this is 8, that's 9. This is 1, this is 2 or 9. So this can't be 8, right? 8, 1 doesn't work, so that's not 8. This has to be less than 6, because 6 times 3 is 18, which I can't fit there in a sum, and that can't be 6, 5. So this is actually fairly small. Oh, 2, 3. These aren't 3. Oops. So this is a 1. So these are the same digit. Let's call those purple now. And that will reappear here somewhere. 1. Oh, I don't think this 1 works anymore. Because if this is a 1, this can be 4. It could be 1, 3, and I have a 3 here. If it's 1, 5, the 3 moves at 1, 4, but then I have 1s looking at both cells. So this can't be 1, 4. So this is not a 1. 4 could be 4, 7, 9, I think. Okay. I still don't think I know this one. This one, no. Well, there's no 1 on it. But that's not so helpful. Okay. Well, what about this one? Because this can't have a 1 on it, because if either of these were a 1, like let's say this is a 1, those two would be the same digit, because 1 times 6 is 6, so this one would be 6. It just doesn't work. Same thing this way. So it has to have a 2 on it, because if it's 3, 4, that's 12, which is too big. So it has to have a 2. And then You can't go 2, 5, so that'd be 10. So it's 2 with either 3 or 4. So this is either 6 or 8. This one's not 4. And this one's a renban. Oh, and this can't be 1, because then those two be the same, actually. So this is also 2, 3, or 4. And not 3. By sudoku. So this is 2. Oh, it could be 2, 2, 4, 3, 6, I think works. So 2, 2, 4 works. If this is 3, oh, if this is 3, this couldn't be 4. It'd be 3, 2, but that'd make a 6, which doesn't work. So that is a 2, actually. Which makes this 4 or 8, depending on if this is 2 or 4. Oh, and if look at this. If this is 4, we get 2, 4, and I get 2 4s in the same box. So that's a 3, 6, which doesn't help me with this one, but I somehow resolved that. I get a 6 over here. That's not helpful. Okay, yeah, but this is also a renban. So this this is 18. So I know what the sum is probably. If this is 1 to 6, that would be 21 minus 9. That doesn't work. So this would be 2 to 7. Let me just check. 2 to 7 is going to be 25 minus 9 is 60. Hold on. What am I doing wrong? 3 times 6 is 18. Right? So then I need for sure 4 and 5, which is 9. So I need another 9, which is going to be 2 and 7. Did I just add that wrong? Oh, I think I just added 2, 4, 5, 7 wrong. That's 18. That's 18. In some order. Oh, this can't be that. Okay, sorry, I had to do another cut for real life stuff. Where was I? This is highlighted, so I think I was looking at this. Well, this column can't be more than 6. It's still 5 digits, and 4 and 5 aren't here. So 4 and 5 have to be here. This can't be 2. This can't be 3. So actually, the most this line could be is 2 to 7. And there's definitely a 6 on it. Oh, there's definitely a 6 on it, which can't be any of those places. It's there. That's kind of neat. And then there's definitely a 3 on it. So there's no 3 here. There's definitely a 2 on it. So there's no 2 here because this can't be a 2. There's definitely 4 on it, but that could go here. Right. Yeah, I think I can go here. Okay. I'm trying to think, is there any way there's no, like, could this be 1, 2, 3, 4, 5, 7? 4, 5, 7. Yeah, that seems all right. Okay. What about this one? Oh, what about this? What about this? What about this? Because this can't have a 1 on it. It doesn't have a 3 on it. So this is 2, 4. This is 2, 4. Whoops. 8, which means that's 6. Yeah, that's good. This is 2, 4, 8. And then that means this renban. Well, this is either 1 to 8 or 2 to 9. So there's an 8 on it, either way, and a 6 on it. And a 3 on it. So here's the 2 and the 4. That's not 3. 3's on it. 5's on it. Yeah, well, there's a lot of choices here. How about this one? 4, 4 would be 16, 7, 9 is possible. Oh, no. Okay, what am I? Oh, this is not 2 or 4 anymore. And this is not 2. Okay, that's a 1, so that's a 3. We need a 2 on this, so there's definitely a 2 here. In fact, I should just get rid of the corner marks because they're not useful anymore. there's definitely 2 with 4 or 5, and this is the other 4. This is 5. So that's a 5. That's 2 or 4. That's 5. That's 7 now. We have a 2, 4, 5 triple here, which puts, so there's no 5 there. No 5 here. 5 is one of these. No, I don't see it. Okay, so this needs 1, 3, 7, 8, 9. This is a 9. So this is 1, yeah, okay. Let's just do some sudoku. 1, 7, 8, 3, 6, 9. What are these digits? Oh, these 3 digits. Oh, 4, 5, look at this. 2, yeah, all this sudoku just available. 7, 8 here. Which means this is 7 or 8, but it's not 8. So these are 7, that's 8. Get rid of that purple. 7, 9 is not here anymore. So this can't be 4, 4 anymore. So this is not a 4. 2, 4, 7. This is not 7. 1, 3, 6, 8, 9, 5. I'm missing 5. 5 is on one of these. Oh, and not here. So that's a 5. That needs a 6, not here. So that's a 6. One of these is a 3. 1, 3, 8, 9, 7. 7 is here in the row. I like that a lot. This is therefore 1 or 9. This is any of them, I think. I'm not seeing any restrictions on that cell. This row has 1, 5, 9. And then what? Then we have 2, 4. Here, so that's the 5. And here we've got 2, 3, 4, 5, 6. So 1, 7, 8, 9 in those 4. So this is 1, 8, or 9. It can't be 1, because if that's a 1, then what would go here, right? Even if it's 9, this is going to be way bigger than 9. So that's not a 1, which means 8 or 9 is here, which means this is not an 8, 9 pair, which means this can't be an 8. Because if this is an 8, that has to be a 9. So that is a 1. We can probably do something now on this, right? Because, oh, no, so let's do this. 2, 9, 8. There we go. The more simple sudoku. So what is this cell? It's not 2. I don't think it can be 4, because if it's 4, that's 32. So this I have to add to 32, which is just not going to happen. 7, 6, 5. This is 4. So it'd be 2, 3, 5, 6, 7. Yeah, that's way too. So this has to be 3. Just make sure that works. 3 times 8 is 24. This is therefore, and this is 11. This is 21. So this is 24. Yeah, 24. Great. So that is the right number. But that just means those 5 digits, those 5 digits. But we get the 3, which means I get a 3 down here. 2, 4, 5, 6. 1, 3, 7, 8, 9. I don't really see much. Yeah, I'm not seeing it. Okay. 1, 1. I get a 1 over here. Is it this one? 3 times 4. 3 times. Could this be 3 times 5? Probably not. What would this be? It can't be 7, 8. So it would have to be 6, 9. But that works. Oh, look at this. Wow, wow, wow. This is neat. If this were a 4, what would happen? Well, this 2, 4 pair and this 2, 4 pair are kind of seeing each other. So these 2 digits have to be the same, right? So start there. Those 2 digits are the same because this is different from this and this is different from this by different Sudoku logic. So these are the same. So these 2 are the same. Which means that if these were 4, where would 4 go in box 6? You'd have to go, it couldn't go into here, so I have to go here, but then I have 4 times 2 is 4, which doesn't work. So these have to be a 2. Like making this a 4 and this a 4. So in this column, I now have just 1, 7, 8. And that's supposed to be a 7. So this is now 1, 8. In this column, I have 7, 9. That's the 9. That's the 1. That's the 7. These are going to be 3 and 9. This is a 8. Leaving 4, 5, 6. Yeah. Okay, I got a 4, 5 pair here, so these two digits are 1 and 2. 4, 5, 6, 7, 8. 7 and 8 are definitely in here and not there, so that's a 7, 8 pair. That's 4, 5, 6 now, which is very interesting how that's going to work. I bet I can do something with that. 1, 2, 3 are gone. I need a 9 for sure. There's no... Ooh, that could be 9, 6, 5, 3. Yeah, okay. 9 is in here. 2 and 3 are up here with... What? This is not a 1. 5, 9. So this is 1, 2, 3. There's going to be something going on here. I don't have X-wing of 1s. So 1 is here. 2, 3. There's definitely a 9 here. Okay, can this be a 2? 2, 4 would be 8. 4 doesn't work. 5, 3 doesn't work. So it has to be 6, 2, which doesn't work either because of this. So it's not 2, 4. Could it be 2, 5, 10? This would be a 4, 6 pair, which does work. Oh, so if this is a 2, that's a 5, that's 4, 6. If this is a 3, 3 times 5 is 15, 6, 9 it would have to be. If this is a 3, 4, 12, 4, 5, 7, 8, that doesn't work. Because this would be 7 or 8, which it can't be. So my choice, there weren't that many choices. It was 2 with 5 and a 4, 6 pair. That's one possible outcome. Or it's 3 with... Oh, 3, 2, this is 5 either way. Hold on, this is 5 either way, right? What happens if this is 4? 4 times 2 means 6. Can't be 5, 3. Can't be 6, 2. So 4, 2 doesn't work. 4, 3 is 12. 6, 6 doesn't work. 5, 7 doesn't work. And 4, 8 doesn't work. So this is a 5. Meaning this is either 10, 4, 6, or 15, 6, 9. Not 4 here. So 6, 4, or 6, 9. Does that mean one of these is always a 6? I think so. Yeah, I think that's right. 1, 2, 3, 4, 4, 5, 6, 9. One of these, so these are from 4, 5, 9. This can't be 4, 9. 13 is not anything. What 1, 2, 3, 6, 7, 8, 9. Okay, 7. I get 7 here. Okay, let's do normal Sudoku. It's always normal Sudoku. 7, 8, 7. 6, 7, 8. No 5 here. One of these is a 5. Hold on. Yeah, if this can't be, one of these is a 5. Yeah, and this forces, I was like, well, how did I not miss that? That's just Sudoku. Very, very basic Sudoku. This is this, which I don't think is worth coloring. 1, 2. Oh, 3 is gone. So that's a 2 now, which means this is 10. So this is 6, 4. This is just a 5, 9 pair now. 5, 9 pair in the column makes this 1, 2, 3, 4. And 4 is definitely here. And this, why is this not 1? Why? Oh, X-wing on 1's here. So this is just 2 or 3. That's not 1 anymore. 1, 2, 3. That's not 5. 9, 5. 9, 5. 1, 2. That's not 9. 1, 2, 3, 8. This is not 1 or 8. This is 2 or 3. 8's looking all over the place. So that's an 8. That's a 1. That's a 9. That's a 3. This is a 1, 6 pair, which I know. Whoops. 2, 4. That's going to be a 9. That's an 8. That's a 1, 8. Yeah, this is all going to unwind now, I think. 3, 9. 2, 3. 4. 2, 4. 1, 3. 1, 2. 6, 4. Look at that. Don't know if that's right. So I'm going to go through and make sure that's right. Hopefully it is. And if it is, you will see this video because that was a really cool puzzle. Really enjoyed that. Thank you, physicist from Funan. Or Funan. Sorry, I don't know how to say that. Anyway, yeah. Thanks so much for watching, and I will see you next time. Bye.